So without further ado, it is my pleasure to introduce Heather Himmelberger. Heather is the director at the Southwest Environmental Finance Center at the University of New Mexico. It's all yours, Heather.
Hi, welcome everyone to today's webinar, and if you've sat through any of our first 3 webinars, welcome back. We're here today as part of the Environmental Finance Center webinar series about asset management. If you recall, this is a project that is funded by EPA headquarters to allow us to help small water systems with the managerial and financial aspects of running their system. And in this project, small is defined as those serving a population of 10,000 or fewer. And the areas that we're working on in this particular project are asset management, rates and finance, water system collaboration, energy efficiency, water loss, and leadership. We've done some in-person training events, and then we're also holding a series of webinars for the various topics. And you can find all the information about upcoming webinars or training and resource opportunities at the Environmental Finance Center Network website at efcnetwork.org. So why do we want to study asset management and learn about it or implement it at our facilities? Well, it really provides us a common sense framework for decision making. It helps us decide how to use our information in the best way so that we can make the best decisions about our assets going forward. It's going to rely on the knowledge of the entire organization. Collectively, everybody who works at the organization, from operators to bookkeepers to managers, finance people, elected officials, all have a lot of knowledge about the organization. If you can collect all that knowledge up together and use that as the basis for your asset management program, you have a very good starting point to work from. It also provides the ability to pass on information. We want to get the information out of people's heads and onto paper. Again, we just talked about how there's a lot of information within the organization, but a lot of that is in the heads of people. They know where assets are located, they know how they performed, but we don't have access to the information without asking them about it. So asset management is going to provide you the ability to organize that information and put it into a format that can be passed on from person to person. It also is going to help move the organization away from a more reactive operation to a more planned operation, and we're going to be talking a lot about that today in the webinar. And it encourages best O&M and capital decisions, which again is a focus of today's webinar, looking at how do we make decisions about operation and maintenance and capital going forward. There are 5 core components to asset management, and hence the reason we have 5 different webinars. We've focused one webinar on each of the core components. The first webinar and the first component was on the current state of the assets, where we get into looking at what assets the system owns, what are the physical things that make up the system. The second component is level of service, which gets into what you want your assets to do. You know, what are you trying to have them provide to the customers going forward. The third component is criticality, and this is where we get into the fact that certain assets are going to be more important to the organization than others. Assets that have a high probability of failure and a high consequence of failure are going to be our high-risk assets, and we really want to focus on those particular assets. Fourth is life cycle costing. This is the focus of today's webinar, and it gets into looking at the overall cost of operating an asset rather than just the capital. And finally, funding, the long-term funding for the organization. How are we going to fund the operation going forward? We're going to do a quick review of the first 3 webinars because we would like this webinar to stand alone as much as possible so that you wouldn't have to have heard the first 3 webinars to really take advantage of what we're talking about today. So in the first webinar, we talked about the current state of the assets, and the main components there are looking at what assets you own. What are the physical things that make up your system? Where are they located? What condition are they in? What's their remaining useful life? And what is their replacement value? When we have all of those things, we now know what our system owns and basically what condition it's in, because it's difficult to effectively manage your utility if you don't know what you have. When you're not aware of what all those components are, it becomes a very difficult thing to manage the overall operation. And this is really the most straightforward component to asset management. Not necessarily the least time-consuming, but the most straightforward. The second component, which was the focus of webinar 2, is the level of service. In this component, we want to remember that water utilities are really customer service businesses. That's what we're focused on. How do we want to meet the customer service requirements? What do our customers want us to do, and how are we going to meet that? It's going to help define how you're going to operate the utility and provide the goals of the utility. And we want that to be measurable so that we know going forward whether we've met the goals. Again, it's difficult to manage effectively if you don't know what your assets, what you want them to do. So I like to call this component the most underappreciated component. People don't like to set goals, they don't like to think about it in this way, but it really helps focus your operation and help you figure out what you want to do and why you're doing it. The third component is the criticality component, and this was the focus of our last webinar. And if you recall, the two main things we were talking about to determine criticality was the probability of failure of an asset and the consequence of failure of an asset. So any asset that has a high probability of failure and a high consequence of failure would fall into this category up here. Any asset that does not have a high probability of failure or consequence would fall down here, and these would be our low risk assets. And the reason we're doing this is to try to identify which components are going to be the most critical for the overall sustained operation, because then it will allow us to have the maximum impact with our limited dollars. So that because we don't have the money to do everything we want, we can focus our dollars very specifically on the high risk assets and really have the biggest impact we can. And I like to think of this as sort of the heart and soul of asset management. When you understand criticality and are able to identify those critical components, it really helps you focus what you're doing and how you're spending your dollars to really reduce the risk overall of your operation. Now today's webinar is going to focus on core component 4, which is life cycle costing. So if you think about what we typically do is we think about a project and we come up with the capital cost of that project, and it would include what it costs to design the project, construct the project, install it, but that's pretty much where it stops. And so traditionally we have just looked at capital costs and how much they are, and we've picked the lowest capital cost project. What we really want to do is get into a mode of looking at overall life cycle costs, which would be all the costs of that asset from the time you put it in place until the time you take it out of service. So it would include everything, all of your operation and maintenance activities, your repairs, rehabilitation if you do it, management, whatever costs you have with that asset. You want to roll all those up over time and really compare the overall life cycle cost of one project versus another, as opposed to just the capital cost of one project to another. And if you think about the change in thinking about it that way, as opposed to just looking at the capital cost, how might that change what you choose to do? So if you had particular projects that you can compare the overall life cycle cost, would that allow you to make different make different decisions as opposed to just looking at the capital cost? And we'll have an example here of what we're talking about. Suppose we have an asset and its initial cost is $100,000, and we decide that we're going to do more maintenance, repair, and rehabilitation to try to keep this asset in service as long as possible. We're going to spend $2,000 a year on O&M, we're going to spend $30,000 in repair cost over the life of the asset, and we're going to rehab it once at a cost of $60,000. That will allow this particular asset to last for 30 years. What if we compare that to a different asset that would do exactly the same thing, whose initial capital cost is $90,000? We're not going to do as much operation and maintenance or repair over time. We're not going to do any rehab, and we'll replace the asset at the end of 10 years. If you compare these two costs over time, a 30-year horizon, so that they're both the same, the life cycle cost of asset 1 is $250,000 and the life cycle cost of asset 2 is $300,000. Now if we just looked at the capital cost, you would want to do project 2 because the initial cost is $90,000 compared to the initial cost of $100,000. But if we look at life cycle costing, we would want to do asset 1. So what we really want to do is look overall at the entire project, the entire life of that asset, and say, what is the best overall economic decision for us to make to have the lowest cost operation we can over time. Life cycle costing is really about balance. We're trying to balance the costs of operation and maintenance, repair and rehab against replacement. We know that if we do more, we know that these costs are related, so if we do more operation maintenance, repairs, and rehabilitation, we can forestall replacement and spend less on replacement. And vice versa, if we do replacement more often, we will do less O&M, repair, and rehabilitation, just like the example that we just saw. However, we know that in general, replacement is a much more expensive activity than the O&M, repair, or rehab are. So the more we fall on the side of replacement, the more overall that's going to cost us, and the more we fall on the O&M side, the less it's going to cost us. So we want to try to balance those costs so that we are replacing when we need to, but we're not doing unnecessary replacements, that we're trying to keep our assets in service longer and meeting our needs so that we can have an overall cheaper operation. We know that maintenance, like we just said, is a good thing for us to do, and there's a couple of different kinds of maintenance. I picked out 3 major types of maintenance here to talk about today. One type of maintenance activities is those routine things that you do just in general to keep your assets running well. Something like maybe changing the oil in a truck, cleaning something out, inspecting it, just those routine things that you have to do to try to keep good operational order. Next is preventative. What are the things that we can do to try to prevent an asset from failure, like replacing a packing gland, or maybe taking a pump apart and putting it back together, cleaning it out, something like that. And then finally, predictive or monitoring maintenance activities. In the predictive technology, we're going to try to predict when an asset will fail. So we're going to have some kind of technology that perhaps can investigate inside a pipe, or maybe it can tell pipe thickness, or maybe it can measure vibration in a pump. Something that will help us try to pick or make a good educated guess about when an asset might fail. So we've talked about the fact that it's great to do maintenance, and there's 3 different kinds of maintenance we can do. However, very often when people are planning budgets, the very first thing that they want to cut is maintenance. Sometimes they cut maintenance almost completely out. So we have to make a case for why maintenance should be put back in the budget, and why we really want to do our maintenance activities, why it's important for the organization to support maintenance getting put back in the budget and getting funded properly. Because generally speaking, it really gets cut, and the biggest impact of cutting maintenance out of the budget, well, actually 2 big impacts are, number 1, it changes you to a much more reactive operation because you're just reacting to failures. You can't get ahead of the curve. And 2, you're going to do way more replacements. So it's going to be more expensive for you to operate overall because you're going to have to err on the side of replacements. And if you think about just an example, you probably have vehicles in your facility, and you have to do some maintenance to those, like replace oil, air filters, that sort of thing. If you didn't do that at all, if you cut maintenance out of the budget for the truck and you didn't do it at all, your truck would run for a certain period of time. But it's going to run a much shorter period of time than if you did that maintenance. So maybe if you don't do that maintenance at all, after 2 or 3 or 4 years, the truck is no longer operable. But if you do all the routine maintenance that you need to do, maybe 10 or 12 years, it's still running. So that you can get maybe 7, 8, 9 more years out of the truck by doing the maintenance. And for each and every component in your facility, the same would be true. The more you can get your maintenance activities done, the longer those assets can last in your facility. So let's look at the concept of maintenance and criticality, because we know that we would love to do all the maintenance that we could, but we're never going to get a budget that allows us to do everything that's possible. So we have to be a little judicious about how we're going to spend our maintenance dollars and our maintenance resources. We probably don't have enough personnel to do all of it, and we don't have the budget. So we'll bring back the concept of criticality and base our maintenance decisions around that. So if we look at routine maintenance, we really do want to do routine maintenance on all of our assets, even our low-risk assets, because we don't want bad things to happen to them because we have ignored the maintenance activities. However, we're going to structure our maintenance such that we want to spend more of our budget on the higher risk assets, so maybe something like 30% for the very high risk categories, 25% for moderate, and maybe 20% for the low risk assets. So we're spreading our maintenance dollars around, and we're doing routine maintenance on all of our assets, but we are again going to focus more on our routine maintenance. And the more our budget gets squeezed, probably the more we would have to focus on those higher risk assets. And why do we want to do routine maintenance? Because if we properly maintain our assets, they are going to last us longer, and we may have to do these activities to preserve warranties. Sometimes if you have a warranty on a piece of equipment, it may require you to do some maintenance activities in order to keep that warranty valid, and you don't want to be down the road and find out that you forgot to do something and now your warranty is no good. Next, preventative maintenance based on criticality. How might this break out? In this case, we'll actually focus a little bit more on our higher risk assets because we know that these assets do have a high probability of failure. So we're getting to that point where they're getting to a condition where failure is quite possible. So we want to really get in ahead of time as much as possible and try to prevent that. And we're going to want to do a little bit more in the moderate risk category down here as well, because again, these are assets that have a higher probability of failure. And we're going to probably do less in our lower risk assets. And again, this is because we don't have all the money we want. If we could do every maintenance activity available, we would want to do that. But when we have a limited budget, we really want to focus over here on those assets that are getting higher likelihood that they're going to fail. And why do we want to do preventative maintenance? If we can prevent an asset failure, we can reduce the consequences of those failures, financial, environmental, and social. So it will really help us, again, economically going forward. And then finally, for our predictive maintenance or monitoring, these activities are going to be more expensive, they're going to be more complex, they may require specialized contractors, they may require special training or special equipment. So we're going to even err way more towards our higher risk assets when we do this kind of activity. So the bulk of our monitoring activity is going to fall in this category, and then the category where the consequence is quite high. In this case, we're trying to do as much monitoring as possible when the consequence of failure is fairly high. We want to make sure that if there is a way to predict that failure ahead of time, we can do it. And we're going to do almost none in terms of our lower risk assets because it's not worth us spending money to prevent the failure when the consequence is fairly low. So why might we do this? If we could better predict an asset's failure, we could use as much of life as possible before replacing. So for example, if we're better able to predict when a highly critical pipe might fail or pump or well, we could use as much as possible of that life before replacing it and still replace it before the failure actually occurs. Now we're going to have a video from Timber Creek, Jeff Yoakum from Timber Creek, talking about preventative maintenance in their particular operation. And again, as a reminder, we're not going to stream the video, just the audio. So Don, if you will, start the video.
Historically, when I was first employed with a sewer company, we had two locations, very small, very, just starting out. There was just myself as operations manager, operator, maintenance person, sweeper down the line. We always had wasn't so much a company philosophy as it was a force of habit of putting out fires rather than preventative maintenance. In the infancy of the company, obviously, finances were always, a major concern. And the biggest change that I've seen is it's allowed us to get out ahead of the problems and to be able to forecast the problems and to take preemptive action to head off those problems and, in turn, the expenses associated with those problems. That's the biggest, probably, asset to the program that I've seen. Secondly, scheduling, because as an operations manager, I function in the office from a maintenance scheduling type of position to actually going out and functioning in the field. So it's greatly increased my efficiency, planning and organization of activities and the maintenance.
Okay. So now we're going to have a poll question. We're going to ask you, if you will, to talk about your maintenance program and what your biggest difficulties are with regards to maintenance. So Lisa, if you would open our poll. Okay, well, we'd like you to look at the question and say, what is your biggest difficulty with the maintenance program? Do you have a lack of an adequate budget, lack of personnel? Do you have both, lack of budget and personnel? Do you have a lack of training or knowledge about what to do? Or hopefully you can fall into category E, which is your program is fine, you don't have any problems with it. So if you will, just take a moment to click on an answer, and we'll see how the responses come out. Okay, so it looks like both A and B is our big winner. About half the people have trouble with both the adequate budget and adequate personnel. We do have 17% of the people that have a good program, which is great to hear. But I think the common answer is probably, or the common thing that we see is probably answer C, where we really don't have the number of people or the budget we would like to have for our maintenance program. Okay, one of the things that doing operation and maintenance activities helps you to do is shift your operation from a reactive mode to more of a planned operation. And the video talked a little bit about that as well, of what it's like to change your organization from being very reactive to being planned. It's generally much more expensive to operate when you're reacting to every failure that occurs instead of getting ahead of them and trying to prevent those activities from happening. In general, it could be 2 or 3 times more expensive for you to be reacting to failures instead of planning. So we want to try to shift from a more reactive mode to a more planned mode. And I brought back an example from a video that we actually looked at in webinar 2, Johnson County, Kansas, where they have a goal of preventative work orders, the ratio of preventative work orders to corrective work orders, and they're trying to shift the organization, or try to shift the organization from a corrective or reactive mode into a preventative mode. And you can see here that the number of preventative work orders for the month was 861 and corrective 159, or for the year 4,336 for preventative and corrective 629, for a ratio of about 86% preventative and 14% corrective. So they have a very preventative or very planned organization. A good goal to shoot for would be about 75% planned and 25% corrective. Certainly the more you can go in the direction of being planned, the better, but at least try to shoot for that. Oftentimes we see the exact opposite, where the planned work is about 25% and corrective is about 75%, but you really want to try as much as possible to shift the operation the other direction. Now we're going to look at a video, or hear a video about this whole idea of reactive versus proactive operation. And I will go through some pictures while the video is playing so that you can get the sense of what the video would be showing. So Don, if you will, start the video.
Here's an example of an asset that we've had a problem with. And when Jerry and I came through here a couple of months ago, we actually took a little movie so we could get the audio so you could actually hear the bearing and the noise that it was making. And then we sent that over to the new maintenance superintendent so he could actually get a work order written, and that's kind of where they're at right now. This mixer right here had a problem, but had we had our PM program up and running and in place, perhaps we could have got to this before we got in this corrective situation where we're actually reacting to the problem instead of actually getting in there in a preventive maintenance mode and heading off problems before they occur. The Access database is very handy because you can filter, you can do search and replace, those sorts of things, and it's really an easy way to collect lots of information very quickly on these assets. Okay, here we have mixture 2539E, and you can probably hear it. It's making a fair amount of noise, and it's also leaking. So probably should be attended to. And sometimes asset management is kind of a nebulous concept, but when we actually have videos like this and actually show people, okay, this is something that needs attention, it needs to be looked at right now, this is asset management in real time. So it has been helpful to the maintenance crew here so far.
Basically what we did before is we kind of did like Dave said, we just kind of ran everything to the point where it failed, and then we went in and replaced it, which is a very expensive and very time-consuming job. So it's a lot cheaper and easier to keep track of it when you got it. There wasn't a way to know that, okay, this mixer hadn't had the oil changed in it in a year. Okay, if they would have got the oil changed in it before the bearing went bad, oil is a lot cheaper than bearings. Basically, oil is one of the cheapest things you'll ever put in. So without having good data and without having a good system where you can put in your PMs and that, you're behind the 8 ball and you're just going to stay there.
So now that you've heard a little bit about the reactive versus planned operation, we're going to do a little poll question. Lisa, if you will open the poll question to kind of look at your particular operation and ask you the question about how reactive and planned you are. Are you 100% reactive and not planned at all? Are you 75-25, 50-50, or are you 25 reactive, 75% planned? Or if you're even less than 25%, you can use that answer as well. So take a moment and think about your particular operation and give your best guess or your best estimate as to how you think your particular operation ranks. You know, how reactive are you versus how planned are you? Are you more like the video we just saw with the situation with the mixer where they really hadn't done the maintenance ahead of time and had the failure? Or are you more like Johnson County where they have been doing really well with getting their preventative maintenance program up and running? Okay. So at least we have nobody, or not too many people anyway, that are 100% reactive, but we have quite a few that are in the 75-25 and the 50-50 ratio. So about 75% or more of us are kind of in that mode of really being a lot more reactive and less planned than we want to be. So that's a place where, for those of you in that category, that we really want to look at that and see what we can do to kind of change our organization around and be a little bit more planned and less reactive. Okay, one more thing that we want to talk about with O&M costs is, in order to do kind of any of what we've been talking about, where you want to kind of monitor your operation, you want to see how well you're doing, and you want to look at life cycle costs, you really need to have O&M costs on a per asset basis. You can't just have overall operation and maintenance costs. Another thing that we see that's very, very common, even in larger organizations, is a general lump sum budget that might say, okay, overall for the whole organization, we spend $10,000 a year on maintenance or $100,000 a year on maintenance, but they won't have it broken down per asset, or maybe it could be broken down between treatment and distribution, but it's not broken down into different individual assets. So you really want to have your operation and maintenance costs broken down by asset so you can see if there's anything unusual going on. You can track your life cycle costs, And you can see if you're actually doing the maintenance. If you have planned that you're going to do a lot of maintenance on an activity, on an asset, and then you see that you've actually spent nothing, you can go back and look and say, well, how come that cost isn't there? You know, what's going on with my organization? So you really want to figure out a way to collect that information on what you actually spend on a per asset basis. Now we'll get into some options of what you can do with your assets. Whenever you have a failure, or when you're looking at being proactive with your assets, when you're anticipating failures, you can do basically three different things. You can continue to repair that asset when it fails, you can rehabilitate the asset, or you can replace the asset. So how might you decide when you're going to repair, rehabilitate, or replace? Well, one of the things is based on economics. So how much would it cost you to rehabilitate the asset? How much would it cost you to replace the asset? Or how much are you going to have to spend to continue to repair it? And sometimes we talked about in the third webinar about financial inefficiencies. When your cost of repair gets so high, it doesn't make sense for you to continue to do that. So obviously one of the big ways you're going to make a decision is based on the economics. You're also going to think about risk. If it's an asset that's a very high risk asset, you may not want to continue to repair it. It may be too critical for you, have too high of a consequence for you that you don't want to continue to repair that asset because you don't want failures to occur. So you may err on the side of replacement or rehabilitation for assets that are higher risk assets. And on the other hand, lower risk assets, we might want to do more repair because we know that the consequence of those assets failing is a lot less. And then we have to think about available technology. Is there a rehabilitation option for that particular asset? Sometimes there is and sometimes there isn't. What is that technology? Is it tested? Is it proven technology? What options do we have technologically to continue to replace? To continue to repair. And then replacement technologies. Is there a better technology that I could use to replace this particular asset so that it might make sense for me to do so? And energy using assets kind of fall into this category sometimes, where if you can get a way more energy efficient piece of equipment that will save you operation and maintenance dollars, you may be driven towards replacement as opposed to any other option, because your operation will be overall better off if you choose that new technology. There's other factors that go into it as well, but primarily we're thinking about, what is the cost implication, what technologies are available, and what is the risk of those particular assets when we're thinking about how we want to continue, whether we repair, rehabilitate, or replace. Deciding when to replace an asset in its life is kind of tricky business. If we just think of a generic asset whose condition is going to decay over time, going to have some kind of repairs going on over time. In theory, for this or any other asset, there's an exact right time to replace an asset. And maybe for this particular asset, the optimal replacement point is right here. The problem is when we get from theory to reality, we generally don't have enough information, and we haven't had enough practice with some of our assets. We haven't studied them or thought about them in this way, that it makes it really, really hard to know what those exact optimal replacement points are for every asset. It's much easier to do if you have shorter lived assets than it is with the longer lived assets that occur in water and wastewater systems. And furthermore, we're always changing the technologies that we use. We have different operations in different parts of the country, so it's hard to compare data. So it's not easy to predict those replacement points. So what do we have to do instead? So instead, if we have a high-risk asset, we're going to replace sooner and have a more planned replacement. Again, because we can't necessarily allow for the failure to occur, or maybe we can have a little bit of failure but not a lot. So if you think about our optimal replacement point was about right in there, for the higher risk assets, we're going to back up that replacement and we're going to do it sooner. And what that means for us is that we're giving up this much life of the asset. So it is going to be more expensive for us, but we're doing that in return for the fact that we don't want maybe this failure or that failure to occur. So that we're saying it's actually better for us to go ahead and replace it sooner because we don't want the consequence to actually occur. We're going to do the exact opposite for our lower risk assets. We're going to replace them later, and we'll call it a managed failure. So we know that the assets are going to fail, but we're going to be ready for how to deal with those failures by having spare parts or trained personnel or whatever. So again, if you think of like the optimal point maybe being right there, we're actually gaining this much life of the asset, but we're having to put up with more repairs and expenses in that regard. So in this case, we're going to spend more in O&M dollars than we should, and in this case we're going to lose some life of the asset. But that's the best we can do, because in many cases, like I said, it's very difficult to predict the exact right point to replace them. So we'll use our risk information to help us make a better choice about when to do that. Here we have a video talking about this very thing. So Dawn, if you would, start the video.
The holy grail of asset management is being able to understand when assets are going to fail. Because if you can, you know you'll replace it at the right time. If we replace assets too soon and are replacing assets on a cycle that's too frequent, we know we're spending too much money. If we replace assets too late after they've failed, then the cost of replacement we know is anywhere from 2 to 3 or 4 times more expensive than if we had replaced it proactively. So we know there's this optimal point of replacing it.
Okay. When we get into replacement of assets, we typically have a capital improvement projects plan, some sort of packaging up of all the projects that we know that we need to do in our facility over time. So the longer that time horizon is, the better off you are, because then you're planning ahead. You're looking forward to what am I going to have to replace in the future. So at minimum, you at least want to be looking 5 years out, but it would be a whole lot better to be looking 10 or 20 years into the future, and even thinking about what's going to come down the pike 50 to 100 years from now, just so that you're prepared for what the big projects are going to be. But again, at a minimum, you want to be looking about 5 years out and seeing, you know, what projects do I have to do? What pumps, tanks, pipe, valves, hydrants, whatever that might be, you want to have them packaged up into a capital improvement plan so that you can look at those plans over time and see what it is you're going to have to do, how you're going to get the money, how that's going to fit into your operation. When you look at your capital improvement plan, you're probably going to see some items on there that are much higher dollar projects than others. Those are the ones that you want to give maybe a little bit of extra scrutiny to those projects so that you can really make sure that you're doing the right things. You want to make sure that you're looked at all the options. You know, were there any other things that I could do? Could I do some more operation maintenance / repairs to keep that in service longer, or do I really need to replace it right now? You might look at, are there other options? Are there rehabilitation options that maybe I haven't considered? You might want to think about things regarding what's my long-term plan for the facility. Do I need this asset 10 or 20 years down the road? Because maybe my operation is moving in a different direction. Maybe I'm having growth in a different part of the community, and maybe it's shrinking in one part, so I don't need the pipes to be as big, or maybe I don't need a pump station or a tank over here or something like that. So you really want to give a little bit of extra scrutiny to those higher dollar projects, because there can be significant savings if you do that. Sometimes we refer to this as the business case evaluation process, where you really just dig a little deeper into those really high dollar projects, really think about, have I really considered all the alternatives, and is this really the best project for me to do, and should I do it right now, or could I do something different? So we have a video again from Kevin talking about some business case evaluation successes that they had in Columbus when they initially started their asset management program. So Dawn, if you will, run the audio.
We had to make some promises to get there. Even though asset management is really a long-term program, it's about long-term sustainability of your infrastructure, we had to come up with some very short-term gains. We implemented a practice called the business case evaluation practice, where we started to really put an extra layer of justification onto our capital projects. Essentially what we said to our own staff is, you have to prove to us that any project that you do will provide more savings in the long run than the initial cost of that project, or the service level increase or improvements that will be delivered as part of this project. Their value has to outweigh the initial cost of that project. And if you can't prove either of those two things, then we will not move forward with projects. I don't think we've canceled any projects outright, but what we have done is really looked at projects and narrowed some scope to keep them really focused on service levels and cost reduction. And we are spending less. We were able to document a long-term savings of over $10 million over the first year of the asset management program for that $2 million investment. So it is really important that you measure the benefits of the asset management program. Sometimes that can be very simple if you can show financial costs have been reduced.
Now, your particular operation may not have capital costs in that order of magnitude where you can have a savings of $10 million, but it's definitely something that can help any size facility. We worked with one particular water utility, a very small water utility, that was looking at replacing pipe that was going to cost it about $5 million. We investigated that project to see if there was something better for them to do. And it turns out that they really didn't need to replace the piping at all. They needed some loop lines, they needed some extra valves, and some fire hydrants, but they really didn't need to do a pipe replacement project. What they ended up doing was alternative activities such as installing loop lines, valves, hydrants, and fixing one particular problem area in their system, and they ended up spending $50,000 instead of the $5 million, and their overall operation is much better, the level of service is higher, and they ended up saving quite a bit of money. So even if you don't have costs on the order of magnitude of Columbus, you can reap considerable savings if you really look a little bit deeper and harder at those capital projects and see if there isn't some other way or alternative for you to do, and see if there isn't some cost savings to be had. We're coming to the portion of our webinar where we talk about what you might be able to do at your own facilities with regards to life cycle costing. And now would be a good time, if you have any questions, to go ahead and type those in as well, so that we can take those at the end. First couple of items we've had on every webinar. If you haven't already done so, develop a team of people that can help you with asset management, and that team can be as small or as many people as you are able to with your facilities. Some smaller facilities will have a very small team, larger facilities will have more, but try to be as diverse as possible and bring in financial people, operators, managers. Get a whole variety of folks to the table, because everybody has sort of a different piece. And so collectively you have a lot of knowledge about your system, and the more diverse your team is, the better off you will be. The second one that we've had on each webinar is to complete the interactive asset management IQ test. It's available on the website as an interactive process, or you can actually download it and do it on paper, and it's a series of 30 questions that kind of helps you benchmark where you are in asset management practice. So again, that kind of tells you the starting point. So if you make changes or improvements as you go forward, it will help you know what the quantity of those changes and measure the improvements that you've made. Now, activities that relate specifically to this particular webinar. One of the things you can do is evaluate your current maintenance program. How much maintenance do you do of routine, preventative, and predictive or monitoring activities? How well does that match up to performing maintenance on the critical items? Do you focus on the critical items? Is your maintenance sort of haphazard? You know, look at that maintenance program right now. What is its budget? How many people are assigned to maintenance? And really think about how reactive your operation is compared to planned or preventative in nature, and really look at, well, how, you know, kind of do a guess if you have to, or take your work orders and compare them to give you a percentage basis of how reactive we are and how proactive we are, or how planned we are, to kind of give you a starting point of where your organization falls. Then think about ways to build maintenance into your current budget. So if you can't have a new budget cycle for another year or so, what are some things that you could do now to build maintenance into your current budget? Is there any area where you could make some changes? Is there any area where you could gain some dollars or personnel time to go and do some maintenance activities? Going forward, how might you gain support to build maintenance into your budget? What kinds of things can you do? Can you come up with a couple of examples in your facility where you actually had to repair something because you weren't able to do the maintenance, and what was the cost of the potential maintenance? What was the cost of the repair? Do you have any examples where you did preventative maintenance and it saved you from having to do repair? Try to package up those examples as much detail as you can, and try to see if you can't build support in your organization for doing more maintenance activities. Look and see if you have costs for O&M by asset. You know, do you currently have enough information that if you wanted to look at one specific asset, you would know what was spent on the operation and maintenance of that asset? If you don't currently have it done that way, how could you do it? Is there a method in your organization where you could get costs by asset? Could you track work orders and people's time on work orders to try to figure that out? Do you have spare parts that are listed and what they've been used for in the organization? What could you do at your specific facility to try to figure out the costs for O&M on a per asset basis? And then look at your CIP program, your capital improvement program. First of all, do you have one? If you don't, think about, you know, should you develop one at least for a 5-year period, but hopefully for 10 or 20 years. And then for the bigger ticket items on your capital improvement plan, are you doing the best option for those items, or are there opportunities to maybe look at something else to do, or some cost savings that you could do to cut the cost of your capital improvement program? Again, we want to thank EPA for providing funding for this project. We really appreciate the opportunity to bring this webinar series to you. And we have our contact information up, and I'll open it up to Dawn if any questions have come in. We have about 10 minutes or so to answer any questions that came up during this webinar.
We had a question come up early in the presentation, and I think that we covered it fairly well, but just to make sure that the person's question has been answered,